Hi everyone. Today we're going to be applying properties of rational exponents. So, if you guys look down below, the first section that we're going to talk about today, obviously, is the applying different properties. Now, before we get going, it might help a little bit to kind of talk a little bit about review of our exponent properties. So, we're going to use these a lot today, at least these three main ones. So when it comes to, I know these aren't like written down in your notes, but if you want to write these down, I would highly recommend doing so. Because depending on when we multiply, divide, or raise a power to another power, just as a reminder, we do specific things for these specific operations to simplify those exponents. So whenever we multiply like bases, the biggest thing that we do with the exponents that we have to remember is we always add the exponents. So, for example, if you look at example number one, here, yes, they're rational exponents, but they still follow all the normal rules of exponent properties. When you have like bases and you're raising them to their individual powers, if you're multiplying those two like bases, then we keep the base the same and we simply just add our bases together. So when I take 1/4 plus 1/2, we get 3/4. So if I take my 3/4, that is going to now become my exponent, and we are considered simplified. Now, if these bases were different, if one was a 7 and one was like a 3, for example, then that's not something that we could have added together. They have to be the like bases. So whenever we look at, for example, like the next one, example 2, whenever we're taking something with an exponent and raising it to another exponent, this is what we call power to a power. And in this case, this is where we don't add them anymore. We multiply the exponents together. So something like this, where it's 6 raised to the 2/3 raised to the 3/5. These we simply just are going to multiply the exponents together. Base stays the same, but when I take 2/3 times 3/5, we're going to be left with 6 to the 2/5. Boom, final answer. For these, it's okay to keep them in exponential form. You don't have to rewrite them as roots. All right. And the last power that we need to review, and this is kind of like that, I mean, obviously it's the opposite of multiplying, but multiplying, whenever we multiply like bases, we add the exponents. Dividing is the opposite. We are going to subtract the exponents. So, like example 3, no matter what kind of exponents we're dealing with, as soon as I see my bases are the same and we're dividing those together, that just tells me that I'm going to take my exponents and we are going to subtract them. So final answer, 2/3. If I take 2/3 minus 1/5, that's going to leave me with 7/15. All right. So if you guys want to pause your video now and try examples 4, 5, and 6, go through and do it right now. All right, answers to 4, 5, and 6 are up now. If you want to check your answers, go ahead and do so. And if you want Miss Hardy to explain one of these, then just go ahead and ask her. Okay. So looking down below, we're going to be talking now about using those properties to help us simplify. So we're going to start off when the first thing we kind of have to recognize, especially when it comes to simplifying things with roots, is they kind of follow the same concept as variables do. So for example, if I was going to take something with variables, so like 2x plus 3x, this is a case where, since we know that the variables are the same, they're being raised to the same exponents, then we know for a fact that we can add the numbers in front and keep the variable the same. Square roots, when we're adding terms with not just square roots, but any sort of roots, we are going to kind of attack this in somewhat the same way. So for example, if you look at like number 8, first thing I see is that we are adding and subtracting. That's important to notice because at some point we're going to switch and we're going to be multiplying and dividing at some point. So multiplying and dividing, we kind of tackle in a different way. Adding and subtracting, it's all about those like terms. And with roots, it's not enough that just the number is the same. The kind of root that you're taking has to be the same as well. So for example, this 6 square root 7, technically 6 root 7, since there's no number listed here, that tells me that that's supposed to be a 2. That's supposed to be a square root, and my thickness is a little too much. Let's go a little farther. There you go. that means that this is going to be that technically there is a 2 there, which means anything else that has a root on this problem has to be something else that has technically nothing written or also a 2. And I only see one more down here. These two guys in the middle, they have the same number on the inside, but they are both taking a different root. They're taking the cubed root. So in terms of adding like terms, I'm going to take 6/7 plus 6 root 7. 6 root 7 plus 6 root 7. Now, just like terms, the square root doesn't change, but the number in front does. 6 plus 6 ends up being 12. And now we add and subtract our other like terms just like we would normally. Technically, we have 8 cube root 7s, and we're taking away 10 cube root 7s. So 8 minus 10 is going to end up being 2. Bring down my cube root of my 7. And that's my final answer. It looks like we should be able to simplify that more, but in this case, we kind of can't. Now, same thing is true when you work through something like this, except sometimes when you're given those square roots, we want to look to make sure they simplify. So if you'll remember back in unit, I think 3, it's been a while, right? But if I have a square root, now keep in mind, square root, we already simplified these back in unit 3. So if I was going to simplify the square root of 8, if you guys will remember, we always started by kind of breaking it down into its factors. So 2 times 4, 4 can break down into 2 and 2. And all of these numbers that are left at the ends of those branches can't really break down anymore. So in square root world, if you guys all remember, we found groups of 2. So we had 2 groups of 2s, which means that is going to go out on the outside. And anything else that's left on the anything else that doesn't have a buddy, we call it the buddy system, right, is going to go back on the inside. Now, what we just did here is exactly the concept we're going to use for any other type of roots. It's just whatever kind of root we're using, we're looking for groups of 3 or 4 instead. So this particular one, the first thing that we want to do is we want to simplify our cube root of 54. So I didn't do that over here because 7 is as simplified as possible. But my root, on the other hand, this is not, because 54 I can break down into 9 times 6. I'm going to keep breaking these down until they can't be broken down anymore. And I think that's about it. Now, because I'm working with a cubed root, that just means I'm going to look for groups of 3s instead of 2s. A group doesn't have to be the 3, the number, but so a number that shows up 3 separate times. So here we actually have a 3. 3 shows up in 3 different places in here. So that's going to go on the outside. Bring down my cubed root. And whatever number doesn't have a buddy, which is 2 in this case, that's the number that's going to go on the inside. And then bring everything else down. And what you'll notice is we actually have like terms. Technically, I have 3 cube root 2s, and I'm taking away 1. 3 minus 1 is going to end up being 2. Keep my cube root of 2. Okay? So if you guys want, please pause your video, and I want to see what you guys can do. Definitely try, I'm going to do a different color. I want you guys to try example 7. And if you want to try breaking down at least the number part of number 10, go for it. And pause. All right, final answer to number 7 is up. Check your answer. If you did not get this enough questions, go ahead and ask Miss Hardy. Number 10, if you just broke down, I know there's a y to the 6 there, but if we pretend that that's not there for just a moment, and we just simplify this as if it was cubed root of 64, hopefully you kind of started with this. Start by breaking down 64. I chose 8 times 8. Keep in mind that's not the only route you could have gone. But I chose 8 times 8, and we're going to break down every single number as far as it can go. So 8 breaks down into 2 and 4. 4 can break down into 2 more 2s, and that's true really of both. Now, if you do this, we're going to look for groups of 3s because we're dealing with a cubed root. And that's why actually here we don't have anything that doesn't go back inside. You just have 2 groups of 3 2s. So both of those sets of 2s are going to come out. We only put one of them down to replace it. Now, you're probably thinking, okay, well, what about this y to the 6? How does this one work? This one works the exact same way. The only difference is Here we're saying, all right, how many groups of 3 y's can we take out? Well, if I have 6 of them, there's one group of 3, there's 2 groups of 3's. So what happens is the square root, there's nothing else, or cubed root, there's nothing else that's going to go on the inside. Here, whoops, 4 is going to come down. Technically, one group of y, one group is going to come out, and two groups of 3 y's are going to come out. So final answer is going to be 4y squared. Okay. So with the variables, you do the same thing. We just look for groups of 3. You just don't have to break them down really. So what I want you guys to do, give it a shot. You guys don't have to do number 12, but I want you guys to try number 11 on your own now. All right, number 11, this should have been your final answer. Final answer, once first of all, we break down the 120. And when you do so, you should be left with one group of 3 2's. So that one group is going to come on the outside. Leftovers, 3 and a 5 don't have a buddy, so those are going to go back in. And now we tackle our variables. Now here again, we're looking for groups of 3's. So out of my 5 x's that are here, right? Out of my 5 x's, this guy right here, there's one group of 3 with 2 left over. So I'm going to take out my one group here, take out my x here, leave the 2 kind of extras inside. Y to the 8th, you know you have 2 groups of 3 y's that can be fully taken out. So 6 total y's are taken out. And there's still going to be 2 left over. Now, if you can't do that in your head, there's no harm in writing that out. If I have 5, 3, 4, 5 x's, we're going to have 1, 2, 3, 4, 5, 6, 7, 8 y's. 3, 2, 3, 4, 5, 6. If you need to write all of those out, that also works as well. Remember, because you're taking a cubed root, we're looking for groups of 3's. So there's 3 x's with 2 left over. There are 3 groups of 3y, 2 groups of 3 y's with 2 left over. And there's 2 full groups of z's with none left over. So that's where you get your final answers outside. Okay? So now what you guys can do, if you want to try some extra ones, you can go try the You Try Nows on the next page, or you can go ahead and start your homework.